Welcome out to video 9 of the Takt Production System for Students course, where I'm going to talk about buffers and delays. And we've attempted to do a really nice job for you in these videos. This one is going to be a presentation of me, and as we go, we're going to keep doing a better and better job of these videos. But this video right here, once we're done with this, you should have all of the key components, and anything after this will literally be bonus. So you have a full masterclass ready for you for the Takt Production System. This is all going to be on the mural board, so this is actually a vision of what the frame looks like. You'll see that we have the pages up here, a presentation called the 12 Ways to Recover with Takt, and then we have an actual guide here from LeanTakt, and then a little image that I want to showcase later on. But one of the things I want to do in this video right now is to play this, and we're not using it for its original intended purpose, it's just a fun video. But the I Love Lucy in the Chocolate Factory video, and we're going to go ahead and play that for you right now because it kicks off our topic. But before we get started, I'm going to ask you to watch this video. It's super cute and it ties into our topic. Okay, so I hope you love that. Like, people just like roar laughing when they watch this video. It's cute, it's funny. But if I asked you what the point is, really you would say that stability doesn't come from pushing. It doesn't come from going faster. They already weren't doing a great job. The key would be to slow down the line, create standard work, and train them, not to speed it up a little. Like, that is just rough. This is a great introduction to this topic today. And so buffers are not laziness. Buffers are not, they're not sandbagging. Buffers are not slack. And buffers are not float. Buffers create stability. Think of anything in life. Freeways are more stable when there's a buffer between cars. Your blood pressure and your heart works better when there's a buffer in your blood pressure and where there's breaks in the beat of your heart. Everything good works from buffers. So this is going to be your board for the course that we'll give to you, and your instructor or your facilitator hopefully will make sure you have access to this. But let's get right into this training right now, and I'll go from segment to segment. So first, let me go to the buffer section. When you have a production plan, you must have buffers in the phase, or at least in the overall production plan. Now, the other day, Steve with LeanTakt pointed out that there's vertical buffers, diagonal buffers, and horizontal buffers. And they actually act differently. Vertical buffers, which are called takt time buffers, are typically for things like holidays or rain days. You're probably not working there. The diagonal buffers are within a sequence, and they're literally to buffer preceding tasks or wagons from successor tasks or wagons. They would be placed, like, for instance, at the end of like steel erection, or hey, we're going to close in the walls and we're going to cover the walls. Now we're going to go into finishes. So these right here buffer sequences. But the horizontal buffers, which will typically end up being your calculated end buffer, are to buffer the entire project from delays and impacts. And I want you to know that a buffer is different from float. Float contractually typically can be shared by you and the owner, or the owner owns it. Buffers are owned by the contractor and are specifically for a delay or an impact. So we have to have them. The difference is when you think about it, Takt, even the concept of a path of critical flow. A critical path has activities, durations, logic ties, sequence. Path of critical flow has activities, durations, logic ties, sequence, and trade flow and buffers. And that's what makes it actually something helpful. So Takt is anti-CPM. CPM wants to get rid of your buffers in your float and push you behind schedule. Takt wants to make sure you have buffers so you can finish on schedule. So let's talk about a couple things. First and foremost, when people visualize, oh, I can put buffers in CPM and I can do the same thing you're talking about in CPM. No, you can't. In a CPM network, you don't zone it properly, and typically the scheduler or the super simply dissolves logic and trade stacks or trade burdens. In Takt, we zone it properly so that you can take that same, by the way, this, and this are the same done differently. CPM Takt. In Takt, we zone it properly, and we're able to gain those buffers so you have stability through zones. It's absolutely brilliant. And in Takt, you can plan a project, have your buffers, and still finish on time even if you hit a delay because you have buffers. In CPM, you can wish list it all you want, but because it's on a critical path and batched improperly and it's a rush, push, and panic system, you're going to overshoot the duration. We've tracked that historically. Takt finishes typically 1 to 5% ahead, even if done like marginally well. CPM finishes on average 20% past substantial completion. One thing I want to mention here is that buffers are not sandbagging. Sandbagging hurts everybody. So if you have honest durations, you'll have buffers that are here for everyone. If you sandbag, that's where trades are padding their activities, but that hurts the overall job. And if one trade is sandbagging, it hurts the other trade partners. And if a trade partner is sandbagging and they accidentally start to do better, it hurts the trade because now you have stops and restarts. Sandbagging hurts everybody. Buffers is not sandbagging. Don't do this. Have accurate representations of the durations and then gain buffers through the Takt Production System. Now here are the buffers that we have in the order of preference. So calculated end buffer according to Eliyahu Goldratt with critical chain. Most buffers, and it can be all, are at the end. In phase buffers, I only keep a little bit there. Most of them I'll put at the end because we want activities to start on time and we want everybody to be able to use them. The second one is the takt time buffers. These are holidays or rain days. We've talked about that. And then we have takt wagon buffers, buffers within the wagon, which the trade actually owns. And the key there is we don't want too much buffer in each task or wagon because then that becomes sandbagging. We want just enough to where they can finish and have a bit of a buffer, and we don't want none because then we'll outrun the takt time, meaning the cycle time won't fit inside the takt time. Here's all you need to know about cycle time and takt time. In-zone cycle time is the amount of time, excluding the preparation time and the queuing time, but the actual time that is required to complete that process in a zone. You want to make sure that your cycle time fits just under your overall takt time for the train of trades in the phase. And then the last one that we have is the in sequence or the sequence buffers that are buffering the latter part of the sequence from the front part. These are the buffer types that I like in order of preference. So I like the calculated end buffer the most. And here's how we do this. In order to, I hope you love this presentation. By the way, this is all here for you, ready to go. In order to know how many buffers you need by phase and then ultimately for the overall project, what you need to do is a risk analysis. What are the risks for these phases, or for this phase rather, in days and dollars? And you don't add 3 plus 3 plus 5. You take the biggest number and you better now have 5. So 1, 2, 3, 4, 5. You have 5 buffers. You have 5 days of risk, 5 days of buffers. The in-wagon buffer doesn't count towards those, and your takt time buffers, your vertical buffers, don't count towards that. So your buffers in each phase are verifiable legally, and they come from the risk analysis. Now you're not doing, like I showed previously, you're not like, oh, there's a solar flare, or Operation Hail Mary, or a nuclear war, or a pandemic, or acts of God. That's not what you're putting in your risk analysis. Supply chain, labor, permissions, weather, unforeseen conditions, those can go in here in your risk. We're talking about reasonable things. So that you can have enough buffers in your overall production plan. Now, the only other thing I want to mention here is when you have a supply chain, you must make sure that you have buffers in your supply chain as well, or you'll end up in trouble. Meaning that if you have buffers inside your phases, you must also have buffers in the supply chain. That way, if you don't need these buffers and it moves forward, you still have your materials. Okay? So that's key. Now, a couple of the things that I want to mention as we go along is that buffers are for unforeseen impacts and delays. But there's some things that in the Takt Production System you can see and get rid of ahead of time and don't need to use a buffer for, like a trade bottleneck, meaning that this isn't pacing with the other trades. Or a zone bottleneck, which means that the zone is too complex. You should just be able to fix those. You don't need to use buffers for those. Now, if you do need to use a buffer, it's great to track it legally so you know where they went, and also to be able to see what's going on. So we have aggregated a list of constraints, which are system problems and roadblocks. So here's a good analogy. Let's say I'm a track runner, and a constraint would be I hurt my knee. That's a system constraint. I am the system. I can't run any faster than my knee. That's a constraint. But let's say that there's a boulder on the track. That is a roadblock. I can remove that. I can't remove my knee injury. This is permanent, temporary, permanent, temporary. And you deal with them differently. So constraints are very different things than roadblocks. But you may have to use buffers because of either. So we have created problem-solving charts, which I covered a lot in the last video, where if you have a constraint, you can know what actions you can take and what the root cause was, what actions you can take and what the root cause was. And for roadblocks, these are the roadblocks, what actions you can take, what the root cause was, what action you can take, what the root cause was. And the most, meaning I'll show you the most commonly used ways to absorb impacts and delays. The first one is just like we've been talking about. There's a delay, you can utilize these buffers here. If there's a delay, you just maintain that cascade and use 2 buffers. That's not a problem. Another one is, it's called a cascaded delay. If you have a delay, you can cascade that not vertically but in the diagonal and use those 2 buffers. So I mostly use buffers for impacts, but you can also isolate it. Let's say that you have a delay here and you are able to switch it from yellow, green, blue, purple to yellow, blue, green, purple. You can change that sequence. Another one is if you have a delay, you can actually isolate the work and pull that out and handle it separately, either from a location standpoint or the activity itself. I use this one the most. Another one is if you have workable backlog on site, meaning crews on the site, you're doing workable backlog. If you have a delay, you can have them come help. Another one is if you have a delay, you can increase their capability if you have another trained onboarded crew. And another one, which is my favorite, if you have a delay, you can rezone behind it to pull in that time. But the key here is that you definitely want to follow these rules, rules 1 through 13. Anything that you do to recover from an impact or delay must be according to these rules. This is actually best done as a poster on your job site. And I do want you, I'm not going to go through these in super big detail because you can read them yourself, but we've also made, in addition, on this same board, 12 ways to recover with Takt. You'll notice some of them. Utilize buffers is one. Change the sequence, you've seen that. Isolate the delay, you've seen that. Add resources, trained onboarded crew or from workable backlog. Rezone behind. So those are things that you're already familiar with, but let me add some more. Let's say that you have a bottleneck. Can you prefabricate or design it differently or change the equipment type to narrow it? We've already talked about this. If you have a trade bottleneck, can you package it to where it's no longer a bottleneck? If you have a zone bottleneck, can you adjust the zone size to where it's no longer a bottleneck? Number 9 is, instead of having big batch durations, can you break everything into zones? But instead of doing 1, 2, 2, 1 to where it's dependent, can you do 1, 2, 1, 2 to where you can sequence behind the other work zone by zone or area by area? I like that one a lot. This one goes back to a previous time where I was on a job site where they scheduled the exterior north, east, south, west, but there's an exterior meaning an exterior sunshade that requires steel outriggers. The actual ideal sequence is 1, 2, 3, 4, 6, 7, 8, back to 5. And you can see that what that's done is that's gotten rid of the bottleneck and pulled it forward. That's another way to recover. One of the coolest ones, which is hardest for me to describe, is sometimes the best way to recover is to hold steady. Don't do anything. Just keep steady with your pull plans, your pre-con meetings, your look-ahead planning, and hold the line. Meaning like keep stability and control work in progress. And the last one is called the Valega method, where instead of pull planning and pacing everything to your one pace setting trade, you actually allow your trades to keep their individual takt time. And this is called multi-train takt planning, single train takt planning. Multi-train takt planning, single train takt planning. So you can optimize this bottleneck, and if this is as fast as it will go, you can also consider having different takt times, which will typically pick up some time. So there's lots of ways to recover here, and it's really neat. And it's all mainly enabled because you have buffers. So we've given you this graphic. This is from the Germans, Dr. Marco Binniger and Dr. Janos Louis, and we've articulated them with expanded descriptions. So if you don't want to have the problem of, we call this the Lucy effect, where you have a problem and it just compounds, then use buffers. And in a production plan, I want to talk about a couple of things. Your buffers inside the actual sequence itself, there should be anywhere between 5 to 20% buffers within the sequence. But that's separate from the actual overall phase. So that phase, the buffers in the overall phase, should be based off of the risk analysis. That's how you do that properly. So the bottom line is, buffers are, let's just say it, I love buffers, buffers love us. And they're the main tool for us to overcome impacts and delays. And impacts and delays will happen, so let's not plan on them not happening. And we've left this all for you on the board. I would recommend taking your takt example and doing a risk analysis and actually figuring out from an example standpoint where you want to strategically place your buffers, and make sure that you are on track to hit your macro milestone. This is where your facilitator will take it from here. You have the board and the resources available for you, and I wish you the best of luck. I hope you've enjoyed this video. On we go.